Having studied the definition of discrete Fourier transform, let us evaluate discrete Fourier transform for some elementary functions. So if suppose xn is delta n, xn is delta n, then what will be its DFT? What will be its DFT? Here capital N कितना है इतना में? Capital N is what will be xk? DFT क्या होगा? xk will be summation n changing 0 to n minus 1 xn e raised to power minus j 2 pi by capital N kn. Okay, summation is performed on n. So what is capital N? Capital N is 1 because there is only one term. Okay, so it means it will be summation delta n e raised to power minus j 2 pi k n, where n is changing 0 to 0. Only one term is there. Okay, so x0 पे क्या वैल्यू होगी इसकी? सॉरी, n इक्वल टू 0 पे क्या वैल्यू होगी इसकी? 1 because it is 1 and it is also 1, so 1 into 1 will be 1. So what will be DFT of delta n? Delta n का DFT will be 1. Similarly, find out the DFT for delta n minus n naught. इसका DFT क्या होगा? Here it will be shifted n naught. This will be n naught, delta n minus n naught, and the summation will be on n naught only because here the one term is on the n naught. So what will be this? यहाँ पे ये n naught हो जाएगा और ये भी n naught हो जाएगा. ठीक है, 0 की जगह n naught हो जाएगा यहाँ पे. इस वाले केस में ये n naught है. So what will be the DFT? DFT will be, इसकी वैल्यू 1 होगी n naught पे और इसकी वैल्यू क्या होगी? e raised to power j 2 pi minus j 2 pi k n naught. This will be the DFT for delta n minus 1. This will be the DFT for delta n minus 1. Of course, k is changing from 0 to n minus 1. K is changing from 0 to n minus 1. Okay. Now suppose we have finite sequence. Suppose xn is equal to a raised to power n for 0, n and n minus 1. इसके लिए निकालिए. DFT निकालिए इसके लिए. इसका DFT क्या होगा? xk equal to summation n changing 0 to n minus 1 xn is a raised to power n, then e raised to power minus j 2 pi by n 2 pi by n kn. This will be the DFT. So it can be written like summation E. What will be the common ratio? It is GP, and the common ratio will be when we take n outside, kept small n. This will be the GP raised to power n, where n is changing from 0 to n minus 1. So it is GP of finite number of terms. GP of finite number of terms. So its summation will be equal to 1 minus e raised to power n 1 minus e raised to power n, because total number of terms are n, 0 to n minus 1, total number of terms are capital N. So 1 minus, because first term is 0, first term is 1, and e raised to power j minus j 2 pi by 2 pi n, because total number of terms are n, 1 minus a e raised to power minus j, and the common ratio is this y k k. Okay, so here it will be not n but k. Okay, common ratio raised to power n, a raised to power n, और यहाँ पे भी n लिखेंगे तो n से n कैंसिल हो जाएगा, then we will get this. Okay, this will be the numerator and this will be the denominator. This will be the DFT of x a raised to power n, x a raised to power n. Okay.